let's understand the working of a stack. So the first the stack is created. Now we want to push a value onto the stack, so we push Ali onto the stack, right? Ali is the value that needs to be pushed on the stack. Then the second one says that push Jack onto the stack, so then Jack gets pushed onto the stack. Then it says pop. Pop means remove the topmost item from the stack, which means we are going to remove Jack from the stack. So Jack has been removed from the stack. Remember, pop always means remove the topmost item from the stack. Okay, so then it says push, and whenever we push something, we also push it onto the top of the stack. So in a stack, everything gets pushed to the top, and it gets removed from the top also. So everything gets pushed at the top of the stack, and it gets removed from the top of the stack also. So when we are going to push Ben, Ben is going to come at the top of the stack. Then we are going to push Ahmed, so Ahmed is going to get pushed at the top of the stack, right? And then we are going to pop, so this is the topmost data value that we have. This is the data value that gets popped, so Ahmed gets popped from the stack. And finally, we have to push Jatinder, right? So Jatinder moves to the top of the stack. So this is our final situation. Once all of these procedures have been called, the push and the pop procedures, right? The final result is that our stack is going to have these three values: Ali, Ben and Jatinder. Then in the question he says that a stack is an abstract data type. It has three operations. We have to create the stack, which basically means we have to initialize the stack, right? And then we can add an item to the stack, and for that we are going to declare a procedure called push. And then we can remove an item from the stack, and for that we'll have to declare a procedure called pop, right? And he's saying that a stack is to be implemented as a linked list of nodes, meaning we are going to have a 1D array. We're going to have a 1D array, and in this 1D array we are going to have nodes, right? And those nodes are going to look something like this, right? So this is what we have, and initially all the nodes are going to be in the free list, and whenever we're going to push something onto the stack, we'll steal a node from the free list, and then add a value to that and then add a value to that node, right? So we'll steal a node, add the value that we want to push onto that node. So that's how a stack works. And whenever we are going to call the pop function, the pop procedure, then that value is going to be removed from the stack, and the node is going to be added back to the free list. So when we are going to add something to the stack, we'll have to steal from the free list, and when we are going to remove something from the stack, then the node that we just removed from the stack has to be added back to the free list. So here he is providing us more description about what the node is like. It has two fields. One of the fields is called name, and the other field is called pointer. And here he has declared an array, a one-dimensional array, which can hold a maximum of 10 elements. This is the upper bound of the array, and this array is going to store nodes inside of it, because this is the data type of the array. Then he says the create stack operation links all nodes and initializes the top of stack pointer. So we have a pointer which is called the top of stack pointer, which obviously is going to tell us where is the top of the stack. Okay, let's go through this exercise once again to understand the behavior of the top of the stack pointer. Now initially all of the nodes are lying in the free list, and what I've done is I've shown this array called stack, and we have 5 elements in this array, which means we can put 5 nodes inside of it, and all of these nodes are part of the free list. And what I've done is I've shown this array upside down. Normally when we draw an array, this is the first element, this is the second element, this is the third element, right? But what I've done is I've shown this array upside down. I've shown this array upside down because it is convenient to think of it this way. When we're dealing with a stack, conceptually it's easier to think of a stack as an upside down array. So the first node, instead of being here, is here. Okay, initially because the array does not have any initially because the stack does not have any values, everything is lying in the free list. Therefore the top of the stack pointer should have some value such as null, or some rogue value such as -1, because -1 is not a valid index of the array. So initially the top of the stack pointer is -1, right? When the stack is created, when this procedure create stack is called, we can initialize top of stack pointer to be -1, which means it is not pointing to any element in the array. Then this push is called, right? When this push is called, a node is stolen from the free list pointer. So the free list pointer moves up because the node has been stolen. That node now becomes a part of our stack, and the top of the stack pointer is pointing towards the topmost node in the stack, which is at position 1 right now, because this is the only node, so this is the topmost node in our stack. Okay, and after that once again another push is called, which means what? We'll have to steal another node from the free list. As a result, the free list pointer has moved up, the new value jack has been added to our stack, and the top of the stack pointer has now moved to position number 2, right? It is pointing towards the second element in the array, because that is our topmost node in the stack now. Then this procedure pop is called, and when pop is called, we'll have to remove an item from the stack. So the top of the stack pointer moves down because we've removed jack from the stack, and the node that was previously a part of the stack has now been released, and it has been added back to the free list pointer. And what you can note is that the released node, it becomes the topmost node of the free list. So anytime we release a node and we give it back to the free list pointer, it gets added to the top of the free list, right? Because the free list pointer is always pointing towards the top of the free list. So next, this push is called. So this value Ben is going to be pushed onto the stack. So once again a node is stolen from the free list pointer. The free list pointer has moved up, and we can see that the top of the stack pointer has now come to the element number 2 of the array. And you can note each time the top of the stack pointer moves, it moves by a value of 1. So it either becomes +1 or it becomes -1. When we remove something from the stack, its value changes by -1, and when we add something to the stack, when we push something onto the stack, then its value changes by +1. So top of the stack pointer becomes 2, value Ben has been added, the free list pointer has moved up, and now this push procedure is called, and this time we are trying to push the value Ahmed onto the stack. Once again, we're going to have to steal a node from the free list. But before we do that, I forgot one thing. These two are linked now, and they should have been linked together when I had pushed Jack also, right? Previously Jack was on node 2. Even then these two should have been linked, because this is where the top of the stack is, and so this is the first value in the stack, and then below this is the second value in the stack. So these two nodes are linked together. Okay, so what were we going to do? We were going to push Ahmed onto the stack, which means we're going to have to steal a node from the free list. So the free list pointer has moved up, right? We've stolen a node. The top of the stack pointer becomes equals to 3, and we are going to add this value Ahmed here, right? Okay, and all of these nodes in the stack are linked, right? This first node in the stack, Ahmed, is linked. The topmost node in the stack is Ahmed, and that is linked to Ben, and then that is linked to Ali, right? So all the nodes in the stack are linked also, right? Then comes this pop, right? Pop means we will have to remove the topmost value from the stack. So now the top of the stack pointer has moved down, the free list pointer has also moved down because the stolen node has been returned to the free list pointer. And finally, what are we going to do? Finally, this push, Jatinder has now been added onto the stack. Top of the stack pointer becomes 3, the free list pointer moves upwards. So I hope you've understood the working of the top of the stack pointer. Okay, so back to the question that we were trying to solve. He's saying that the create stack operation links all the nodes, which means it's going to link all the nodes in the free list together, because right now we do not have any data onto the stack, right? This is the create stack operation, right? So this is where we are doing all the initializations, right? So the create stack operation links all the nodes and initializes the top of the stack pointer and the free pointer, right? So complete the diagram to show the values of all the pointers. Okay, now this time what he has done is he's not showed our stack upside down. When I was just working with the stack, I was drawing the array upside down. So my first node was here and the second node was here, so that my stack could grow upwards. Anyways, he's not done it this way. He's shown the stack downwards. So what's going to happen is that all of these nodes are linked together. Remember, this is a free list, so this node should be linked to this one should be pointing here, so the pointer values should be pointing to the next nodes, right? So this should be 2, this should be 3, this should be 4. So I've quickly linked all the nodes together. You don't need to draw these arrows, I'm just drawing these for conceptual purposes, right? Okay, so each pointer is pointing towards the next node, which is lying in the array. So this is how all of these nodes are linked up. And finally, this final node, which is node number 10, this is the last node in our free list, so it's not connected to anything else, so we can use a rogue value here, and a good rogue value here can be 0, because the valid index values are from 1 to 10, so we can use 0 here. Okay, so 0 indicates that the 10th node, the 10th element has a node which is not connected to any other node. Okay, let's decide on values for our top of the stack pointer. Initially, the top of the stack pointer is not pointing anywhere because we don't have any data on our stack. So we are going to use our rogue value 0 to indicate that this is not pointing anywhere on the stack. And the free pointer value, the free pointer should be pointing towards the first node in our free list, right? So its value should be 1. Then what he's doing is he has provided pseudocode. In the question, he's provided pseudocode for this procedure push. Remember, push is a procedure to add a value onto the stack, right? And then he's given us this identifier table where we know what a stack is, and new name is the parameter that is being passed to our procedure push, right? So this is the value that has to be added onto the stack. What else? We know what free pointer is, we know what the top of stack pointer is doing, and there's something called a temp pointer, and it's a pointer which is going to temporarily store the value of going to temporarily store the value of free pointer. Okay, so we'll probably be needing this when we are trying to steal a node from the free pointer, right? So remember, this is a procedure where we have to add something onto the stack, and when we have to add something onto the stack, we have to steal something from the free list, right? We have to steal a node from the free list, and probably this temporary pointer is going to be used at that point in time. Let's take a look at the code, quickly understand it. See, what he's saying is, if free pointer is null, if free pointer is 0, if free pointer equals 0, that means we do not have any free nodes. when we don't have any free nodes, we can't add anything onto the stack. So he has chosen to output a message or say something like report an error. Okay, so if the stack is full, then report an error, because the free pointer is 0 means that there are no more free nodes available in the free list. Okay, but if the free pointer is not 0, that means we come to the else part. Now we have nodes available in the free list, right? So the first thing that we are going to do is we are going to steal a node from the free list. Okay, before we steal a node, what we are doing is, in our array called stack, the node towards which free pointer is pointing at, that node has two fields, and one of the fields is name, right? So in our array stack, the node towards which free pointer is pointing at, its field name should be given this value new name, right? New name was the parameter that was being passed. So the node that we are going to steal, its field name has been given this value new name that has been passed as the parameter, right? Remember, this is the node that we are trying to steal, the node that free pointer is currently pointing at. Okay, so now what we do now is we store the value of free pointer into temp pointer. So we assign temp pointer with that value. Okay, so let me just quickly draw the free list here, right? So remember, this is our free list, right? This is our free list, and this is where the free list pointer is pointing. I'm just going to say FLP, right? This is where the free list pointer is pointing, right? And this is our array called stack. So what we've done is, this array has a node, and that node has two fields. One of the fields is name, and the other field, I believe, was what? The other field was pointer, right? The other field was pointer. So the second field is pointer. What we've done is, using the free list pointer, we have updated this value of name by using this parameter new name. That is what we are doing here, right? So the node in our array stack towards which free pointer is pointing, its field name is given this value new name. Once this has been done, we say that the temporary pointer is pointing towards the free pointer, is given the same value as the free pointer, which means the temporary pointer, and I'm going to call it TP just for reference, the temporary pointer is also pointing to the same node. It is pointing to the same node that the free list pointer is pointing at. Now we can move the free list pointer to the next node, right? And remember, this pointer was pointing here, right? That's how we initialize the free list, right? So what are we doing? We are saying that the free list pointer, and he's calling it the free pointer, right? So the free pointer is going to be updated. It's going to be given a new value. So in our array stack, the pointer towards which the free list pointer is pointing at, and remember, right now it is pointing here, right? It has not been updated. So in our array stack, the node towards which free pointer is pointing at, that node's pointer field, which becomes this field, right, its value is now being given to free pointer. So free pointer is now going to move here to the next node. Free pointer has been updated. We have the node available to us. Now we are going to link this node into our stack, right? So this is what we are doing here. We are saying the stack, the array stack, in the array stack, the node towards which the temporary pointer is pointing, and that's this node, right, the one that we just stole, its pointer value, right, should be set to the value of top of stack pointer. And remember, initially the top of stack pointer is 0, which means what? Which means that the top of stack pointer, this node, which has now become a part of this topmost node, which has now become a part of our stack, and the temporary pointer is pointing here, its value is set to 0, right? Because the top of the stack pointer was initially 0, which means what? This is the only node in the stack, and it makes sense because this is the only node in the stack. It's not connected to any other node, right? and all of these remaining nodes now belong to what? They now belong to the free list, and the free pointer is pointing here. So that's the situation up till now. And the name, whatever that name was, let's suppose Ali has been added here, right? And then the top of the stack pointer is made to point towards the temp pointer. So what we are doing is, before we updated the top of the stack pointer, before we updated it, we set the value of the new node that we were just going to add. You know, the temp pointer is pointing towards the current node, the node we are just about to add to the stack. I should not call it the current node, I should call it the new node. The new node that we are just trying to add to the stack, its pointer value has been set to the top of the stack pointer. So wherever the top of the stack pointer was previously pointing, wherever it was previously pointing, that value has now been assigned to the newly added node, right? And then the top of the stack pointer is updated to point towards the newly added node, because the temp pointer is pointing towards the newly added node. So the top of the stack pointer is going to point here. So we're going to try this push procedure one more time to understand how it works. This time this call push Ahmed has been made. So new name is basically, you know, this value Ahmed is being passed as the parameter, right? So once again we check if the free pointer is 0, and remember this is our current state, right? I'm using TOS to you know, just write, TOS is short for top of the stack pointer, and FP is short for free pointer, right? So right now what we just did was we added Ali onto the stack, and remember we had set the pointer value to 0, right? And let's see how this works, right? Because we're now trying to add another node, right? So we're trying to push something more onto the stack. So once again this code we're going to have to use. So first we'll check if free pointer is 0, and the free pointer is not equal to 0, because free pointer is equal to 2 right now, which means it is pointing to the node lying in the second element of the array, right? So that means we come to the else clause. In the else clause, what is the first thing we do? We say stack free pointer. In our array stack, the node towards which free pointer is pointing at, its field called name, give it the value that has been passed at the as the parameter. So here we are going to write Ahmed as a result of this instruction. So once this instruction gets executed, temp pointer is set to point to the same node that the free pointer is pointing at, right? So TP also becomes equals to 2, and temp pointer is also pointing to this node, right? Now what do? Now we move the free pointer forward, right? And to move the free pointer forward, we are using the node that the free pointer is already pointing at. So we are saying in our array stack, the node towards which free pointer is pointing, which is this node, right? Node number 2, take its pointer value and give it to free pointer, right? And remember the pointer value here is 3, right? Which means what? Free pointer now becomes equals to 3. Free pointer now becomes equals to 3, which means it automatically points to the next node. So this is the new node that we've just added, remember? And this should be linked back to this top node, right? Because now this is because I should not call it the top node, right? This new node that has been added, it should now be linked back to the node that was previously there onto the stack, right? Remember this is the stack this is the node that has been newly added. So this becomes our new node, this becomes our top node in the stack, right? So Ahmed is the top node in the stack, and below Ahmed is Ali. But we need to link this back, right? We need to link Ahmed back to Ali, right? So let's see how are we doing that. We are saying that in our array stack, the node towards which temporary pointer is pointing, and remember temporary pointer is pointing here towards this node lying in the second element of the array, right? This node, its pointer value is this value, right? This needs to be set. What is the new value that's going to be given to this pointer value? The new value is that of the top of the stack pointer. And where is the top of the stack pointer right now? It is still at position number 1. So which means what? This will be updated to 1, meaning we've linked this back to this, because what we are saying is that this pointer is now pointing to node number 1, element number 1 in our array. So we've linked this backwards, right? And now we can update top of the stack pointer, and top of the stack pointer now becomes equals to temp pointer, which means what? TOS will now become equal to 2 because temp pointer was 2. So TOS will now point to this node, and this becomes the top node in our stack because top of the stack pointer always points to the top node in a stack. So you see how this code is working, right? It is efficiently adding new values to the stack, and it's stealing those nodes from the free list, and it's also making sure that the new node in the stack gets linked back to the previous nodes in the stack. Okay, next he says that we have to complete this procedure called pop, and remember, pop is a procedure where you have to remove an item from the stack, and he's given us an incomplete procedure. So let's take a look at what he's saying. What he's saying is that we have to report an error if the stack is empty. Remember, as soon as we go into the procedure pop, we'll first check if the stack is empty, and if it is empty, then we're going to report an error. And obviously, if the top of the stack pointer is 0, then that means that our stack is empty. In that case, we are going to output an error. But if the top of the stack pointer is not 0, then comes the else part, right? So we must write this else. Remember, this was missing here, so we can't make these mistakes, right? Because there on, the code moves on. He's trying to do something else, right? So we must be careful. We not only have we written the condition that the top of the stack not only have we written the condition that if the stack is empty, output an error, we also must write this else here, because this else is very important. So if the stack is not empty, then comes the else part. So what do we do in the else part? He's saying that we have to output something, right? And we have to output the name. So most likely we are going to output the name of the item that we are going to be removing, right? So the item that is currently at the top of the stack, its name should be output. So that is exactly what we are doing here. We are saying that in our array stack, the pointer towards which top of the stack pointer is presently pointing at, its name value should be output. And then he says what? Take a copy of the current top of the stack pointer, right? So what he's basically saying is that store the value of top of the stack pointer into some other variable, right? And remember, the variable that we had for temporarily storing pointer values was the temp pointer, because that is exactly what we are saying. Take a copy, meaning store the value that is lying in the top of the stack pointer into some other variable. So that is what we've done here. We've assigned the value of top of the stack pointer to temp pointer. And next he says that we should update the value of top of the stack pointer. So no wonder he's asking us to store the top of the stack pointer value into the temp pointer, because next we are going to update the top of the stack pointer. So the top of the stack pointer is going to move. Because top of the stack pointer is going to move, the node that the top of the stack pointer was previously pointing at, that is going to still be pointed at by the temp pointer, right? Because here's what we are doing. We are saving the value of top of the stack pointer into the temp pointer, and now we can update the top of the stack pointer. So when we are going to update the top of the stack pointer, this top of the stack pointer is going to point to some other node, right? And the node that it was previously pointing at was the node that we are about to remove. So this removed node has to be added to the free list, right? So some pointer we should always have available to point towards this node that we are about to remove, right? Because we have to add this removed node back to the free list. So the temp pointer will do the job, right? Even though the top of the stack pointer has moved, the temp pointer is still pointing to the node that we are trying to remove. And by removing, we mean we are going to remove it from the stack and we are going to add it back to the free list, right? So when we are going to add it back to the free list, that's when this temp pointer is going to come in really handy. So let's update the top of the stack pointer as is required here. But before we do that, just one thing, remember this was the example that we just did, right? This was the example that we just did, and our top of the stack pointer is pointing here right now. It's pointing here. Let me use red so that you can see, right? So this is where the top of the stack pointer is pointing right now. This is our top of the stack pointer, and you remember that we linked it back to the previous node, right? So now we know that if we want to remove this node, right, with Ahmed inside of it, if we want to remove this node from the stack, we have to move this top of the stack pointer to point to the previous node in the stack. And remember, the previous node in the stack is the one that this node is pointing at, is the one that Ahmed is pointing at, and Ahmed is pointing towards Ali, right? So Ali is the previous node, right? So we are going to use this pointer value to update our top of the stack pointer, and that is exactly what we've done here. We've updated our top of the stack pointer, and we've updated it by using the node that the top of the stack pointer is already pointing at. So the array stack, in our array stack, the node towards which top of the stack pointer is pointing, its pointer value is used to update the top of the stack pointer. So that way the top of the stack pointer moves back to the previous node. And then he says, now we want to link this released node back to the free list. And remember, I told you previously also, when you have an existing list, and I think I explained this in binary trees, or if it was linked list, I don't remember. When you have an existing list like a free list, right? So the free pointer is pointing towards this free list, and then this is connected to another node, and this is connected to another node, right, and so on and so forth, right? So this is our free list, right, all the free nodes. And now we have another node which is currently being pointed at by the temp pointer. So the temp pointer is pointing to this node, right? This is the node that we've removed from the this is the node that we've removed from the stack, right? Now I told you previously also, think of this like a new node that is going to be added to the free list, right? Because for the free list, this is another node, a new node that is being added. And remember, whenever you have to add a node to an existing list, just remember this, the linking is very important, the sequence is very important. First make this node point towards this node, first make this node, its pointer value point towards the node that the free pointer is already pointing at, right? So now there are two nodes pointing here. Once this linking is done, then you link the free pointer to this node, okay? If you get your sequence wrong here of connecting these nodes together, then then this code will not work. And that is exactly what we've done here. The first thing that we've done is that the node towards which temp pointer is pointing, remember this is that node, right? Its pointer value is being updated, right? So its pointer value is being set to the pointer value of free pointer. So this pointer will now point to the same location that the free pointer is pointing at. So this pointer is now pointing to the same location that the free pointer is pointing at. And once this has been linked to this node, now we can move the free pointer to point to this node. And remember, to this node the temp pointer is pointing. So we've set the value of free pointer equals to temp pointer. And finally we've closed our end if. Remember, this was where we started with if, and then all of this is the else part of the code, and finally we have our end if here.